Good morning students. Today we are going to start the new chapter, metals and non-metals. What are metals and what are the non-metals and what are the topics we are going to cover in this video is classification of elements and means how the elements are classified and what is the occurrence of metals and the physical properties of metals, chemical properties of metals and the uses of metals. All these topics we are going to cover in today's video, right? Okay, let's start our video today. See, first of all, what is the occurrence of metal? Otherwise, what is the classification of elements? First, before going to the occurrence of metals, what is the first classification of elements? How can we classify the elements? See, elements can be classified into 4 types based on their properties. First one is metals and second one is non-metal, metalloids and inert gases. Overall, all the elements in the periodic table is considered 118 elements are there. Out of 118 elements, we know the particular properties for 90 to 96 elements. So, for those elements, based on those properties, and we came to the conclusion all the elements can be classified into 4 types: metals, non-metals, metalloids and inert gases. Like among the total elements discovered, approximately 80% of them are metals only. Means most of the elements in the periodic table or most of the elements which are existing, those are 80% are metals. Remaining 20% there will be non-metals, metalloids and inert gases, right? So, here in this point, what is the classification? Metals, non-metals, metalloids and inert gases, right? So, what is the occurrence of metals? See, how the metals are occurring in the atmosphere? They will be occur in the free state as well as in the combined state. Some of the elements will be occurred in the free state, some metals will be occurred in the combined state. See, which type of elements we are getting in the free state? See, some metals, gold, which we use for the ornaments, silver, gold, silver, platinum, these are very least reactive. They will not react with other elements, they are very least reactive. Inert gases, they will not react with anyone, but these will react, but they are very least reactive when compared with the others. So, these type of elements are combined in the free state in the atmosphere. In uncombined state means most of these metals, not only these three, these are in free state, most of them they will be formed combined state, means they will react with the oxygen present in the atmosphere and they form respective oxides, so hydroxides like that. But these are existing in the free state. Now, which one are existing in the combined state? See, reactive metals like iron, aluminium, calcium, magnesium, etc. These metals will be occurring in the combined state because these are very reactive. If we keep the metal like that, they react with the oxygen present in the atmosphere or different types of gases and they forms the respective mixed compounds. Because of that reason, these metals are existing in the combined form. They forms the oxides, sulfides, sulfates, carbonates and chlorides like that they will form. They will react with the other elements and they forms these type of compounds, and that is why they are existing in the combined state. Examples of FeS means iron sulfide, aluminium oxide, aluminium is existing as aluminium oxide, calcium will react with carbon and oxygen and forms calcium carbonate. So, these are existing in the combined state, right? So, first of all, let us see, first we have classification for 4: metals, non-metals, metalloids and inert gases, right? So, in this video we are going to study completely today about the metals. Means what are the physical properties of metals, what are the chemical properties of metals and what are the uses. Come to the first one, physical properties of the metals. We know it is very easy. What are metals are sonorous in nature. Suppose you see in our house we will have a steel, that is an Li, okay. But if you throw that, it makes some sound, right? So if you see the bell in the temple or bells in the schools, they'll ring, they'll make some noise, that is called sonorous. Most of the metals are sonorous in nature. Sonorous is nothing but they'll make the sound, they'll make some sound. We have some metals. Sodium is a metal. If you throw that, it will not make any sound. It is a soft metal. We have some exemptions. See, metals are solids. Come to the first one. Metals are solids in nature. Most of the metals, they are solids. Most of the metals are solids except mercury. Mercury is a metal, but if you keep with that palm, it will be in a semi-solid state, and we cannot touch with our hand also. If you touch that, it again divide into the smaller parts like. So mercury is a semi-solid, that is in a liquid like. So except mercury, most of the metals are solids and they are hard in nature. But sodium, potassium, we can cut with the knife. They are called soft metals. This is the exemption. Most of the metals are hard in nature, but except sodium and potassium, they are soft in nature. We can cut them with the knife also. And see, metals have metallic luster. That is what lustrous means. They will have shininess. In our home, you see the steel, it will be shiny in nature, right? So they have some shining nature. That is called luster. Most metals have melting points and boiling points. Yes, they have high because they are hard solids, because they are very hard solids. Suppose iron is there, iron is the metal, we can't melt the iron at the stove, at whatever the home we have a stove, that one we have a separate high temperature is required to melt that metals, isn't it? So they require high melting and boiling points. Metals are malleable in nature. What is meant by malleability? Means we can make them into thin sheets like. Make them into thin sheets. Thin sheets, see, gold is highly malleable in nature. Why? Platinum is also malleable in nature. Silver, malleable in nature. That's why we are making very smooth ornaments, very small ornaments. Small model we are taking. Why? Because they are highly malleable in nature. Means we can beat it into thin sheets, whatever the shape we want. In atomic structure, Rutherford's alpha ray scattering experiment, he taken the gold foil only. Why? Because we can beat into the very thin sheet, 0.01 millimeters, like we have taken the thin sheet in that experiment, right? So these are highly malleable. At the same time, they are ductile in nature. How malleability is nothing but beaten into the sheets, like that. This ductility is nothing but thin wires like. If you see, while doing the gold ornament, they will keep the gold in the small hole and they will pull it, come out as a wire, very thin wire. That's why whatever the model we are giving, that gold workers, they will do that model, because gold we can melt, we can make into very, see, however we want, we can mold with particular temperature, right? So metals are ductile. Metals are good conductors of heat and electricity. Yes, because metals lose electrons. When they lose the electrons, electrons mobility will be takes place. So they are the highly good conductors of heat and electricity. This is the last point. Metals are sonorous, means they will make the sound. Most of the metals produces the sound. So those are the sonorous. So what are the physical properties of the metals? First of all, most of the metals are solids except mercury, and most of the metals are hard except sodium and potassium. Those are very smooth and we can cut with the knife also. And most of the metals are high melting and boiling points they have. And metals are malleable and ductile in nature, means we can thin sheets and we can draw into the wires like. And most of the metals are sonorous, and most of the metals are good conductors of heat and electricity. So generally these are the physical properties of the metals. Means what is physical property? Its shape, its size, its color. If it is a gas, what is the smell, All these are the comes under the physical properties, physical appearance of the metal. Now come to the chemical properties of the metals. What is meant by chemical properties? Chemical properties is nothing but by using this metal preparing new compounds, means these metals react with some reactants and they produces the new compounds. Those are called chemical properties of those metals. Okay, let us see. What is the first one? Reaction with oxygen. What is the first one? Reaction with oxygen. What happens when metals react with oxygen? They forms oxides. They forms metallic oxides. Metals reacts with oxygen, forms metallic oxides. See, take here one example. Magnesium is a metal. It is reacting with oxygen and forms magnesium oxide, MgO. If this magnesium oxide reacts with water, forms magnesium hydroxide, MgOH taken twice, magnesium hydroxide. So what happens when metal reacts with the oxygen? Forms the metallic oxides. Anything, suppose take aluminium. Aluminium reacting with oxygen forms aluminium oxide, means aluminium trioxide, Al2O3. You have to balance the equation, 2Al plus 3O2. All the metals, they forms the metallic oxides. Now come to the next chemical property. Reaction with water. When metals reacts with water, what happens? When metals reacts with water, they forms metallic hydroxides. See, sodium is the metal which is soft in nature and highly reactive. When, see, sodium we store in the kerosene, because if we keep for the open air, sodium and potassium are highly reactive in nature. Immediately they reacts with the elements present in the atmosphere and forms respective compounds. Sodium immediately reacts with the oxygen and forms the sodium oxide. Iron, if you keep for more time in the atmosphere, it forms rust. But to form rust, iron will take minimum 6 months or 3 to 4 months. Gold, if you keep for the open air, it will not form any rust or anything. The shining will be like that only for so many years. That's why we can say. But sodium, if you keep for 1 second, it immediately reacts. So this represents the reactivity of the metals. Sodium is highly reactive, that's why immediately it is forming sodium, and immediately that's why we are keeping that in the kerosene. Non-polar compounds. Like that only iron, it is a medium reactive, and gold, it is less reactive, right? So when sodium reacts with water, immediately it forms NaOH, means sodium hydroxide, and it produces some gas, that is hydrogen gas. Even magnesium reacts with the water, produces magnesium hydroxide and hydrogen gas. What happens when the metals reacts with water? They forms the respective hydroxides and hydrogen gas. They releases hydrogen gas, right? Now, reaction with acids. When metals react with the acids, see here, zinc is the metal reacting with HCl, means hydrochloric acid. What happens? H2 like comes out, then zinc displaces the hydrogen's place. Zinc will take the hydrogen's place because zinc is more reactive than hydrogen, so zinc can displace hydrogen. So hydrogen comes out. So simply it forms ZnCl2 plus H2. So Zn reacts with 2 moles of HCl, forms zinc chloride and H2, right? So metals replace metals, that is what? Metals replace metals. Highly reactive metals can replace the less reactive metals. Highly reactive metals can replace the less reactive metals. To understand this reaction, we should know the reactivity series of the metals. We should know first of all which metal is highly reactive, which is less reactive, which is moderately reactive. See here. This is the activity series of the metals. In a regular, we use these metals. If you see the See, reactivity series here, potassium is in the first place, means potassium is highly reactive. After potassium, sodium, next magnesium, aluminium, zinc, iron, lead, copper, next silver, next gold. Gold is in last position. This is the reactivity series. See here, if you see the potassium, in between lead and copper there will be the hydrogen. Before the hydrogen those are highly reactive, after hydrogen those are less reactive, like we can say. So here in this lead, suppose see sodium and magnesium. Sodium is more reactive than magnesium. So sodium can displace the magnesium in a reaction, but magnesium cannot displace sodium or potassium. Why? Because highly reactive metals can displace less reactive metals, but these less reactive metals cannot displace the highly reactive metals. This is called displacement reaction, single displacement reactions. So here we are studying that single displacement reactions only. See here, magnesium is given, copper is given. If you check our reactivity series, magnesium is here, copper is here. Which is more reactive? Magnesium is more reactive. So magnesium is more reactive than copper, so magnesium can displace the copper. So the product is magnesium sulfate and copper comes out. This is what the experiment will done in the lower classes, FeSO4 and CuSO4. Iron can displace copper. In a copper sulfate solution, if you keep one iron bar and leave for 24 hours, that blue color solution will turn into green color solution. That is nothing but copper is displaced by iron, right? So this is the displacement reaction. This is the activity series of metals. And last one, in the metals, we have noble metals. Like noble metals means they will not react. They are not react means already you got some idea. What is that? Gold, silver, platinum. Why platinum is that much cost than gold? Gold is only cost because of that shining capacity and that unreactivity nature. Silver is cost, then that gold is cost, then the gold, platinum is cost because of all these properties, shining property, malleable and ductile, we can bend that and we can get whatever the shape we want. That's why ornaments we will see with the very minor designs also, right? And they will not react, that shining will be like that only. If you buy an iron bar for 1 lakh rupees, within 2 or 3 months wherever you keep, immediately it starts rusting. But you keep the iron or gold ornament for 10 years also, the shining will be like that only. That is gold, right? So these such type of metals are called noble metals. Noble metals like gold, silver, platinum, gold, silver, platinum are retain their luster because they do not react with air, water, acids. That's why those are called noble. Noble means ideal metals. They will not react for anyone. That is called noble metals. Gold dissolves in aqua regia. What is meant by aqua regia? Aqua regia is nothing but concentrated HNO3 plus concentrated HCl mixture in the ratio of 1:3. Means 1 ratio of HNO3 and 3 ratios of HCl if you take, that is called aqua regia. Only gold can dissolve in that regia, in that mixture only. Other than gold will not dissolve. So pure is 24 karat gold. Whatever we are taking now, cadmium or 916 gold, that is nothing but only the purity is 91.6. Means only 91 for 100 grams, 91.6 grams only the gold, and the remaining will be the copper or like that they will mix. Pure gold, only gold if you want, that is 24 karat gold. Means 100 gold ornament will be there. That's why that is more cost. So it is very soft, cannot be used for making ornaments. That's why we prefer 22 karat gold or 916 gold, because we have to mix at least some copper. So it is mixed with some silver or copper to make it hard, because that is smooth. That's why 24 karat gold. Biscuits like we'll keep, but while doing the ornaments we'll take the 22 karat or 916. Okay, so this is about the noble metals. Now come to the uses of metals. So in this video, what are the classifications and occurrence of the elements? Classification of elements, occurrence of the metals, physical properties of metals, chemical properties of metals. Now what are the uses? See, uses: iron. For what purpose iron will use? For the construction purpose. For house construction, inside they will keep the iron bars. Iron like this they will keep for the strong construction, for the basement also, right? So for the buildings, bridges, pins, nails, nuts, bolts, tools, machines, construction of buildings, for all those purposes iron will be useful. For what aluminium is useful? It is used for making utensils, whites, furniture. For all these purposes aluminium. Copper is used for wires, vessels, electric gadgets. All these are for copper. Gold is used for ornaments, jewelry, coins, medals, gold medal, medals. And silver is also same for making jewelry, coins, medals, silver medal like. And platinum also used for making jewelry. Platinum jewelry very costly, right? And electric gadgets, plugs and vehicles, etc. This platinum they will be used. And sodium, its compounds are used as common salt and chemicals, etc. And calcium used for making cements, glass, for such things. These are the general uses of the some of the metals. Okay, so this is about the metals and non-metals in about the metals. Okay, in our next video we will go with the non-metals or metalloids and inert gases, right? Okay, thank you so much.